So I'm only doing this for the video, so for anyone who isn't here. We're making the unit circle, keep going, I'm just recapping for the video. You know how it is. By drawing a coordinate plane, starting off by drawing 30 degrees, 45 degrees, 60 degrees, which we have up here. We should put 60 degrees, we should put our degrees. No naked numbers, remember. So if it's 60 degrees, it gets a degrees. And then coming up on the other side with 50 or our 30 degree reference angle, our 60 degree reference angle, our 45 degree reference angle, and build these three. And then all you have to do is connect the lines, and you're still going to get your 30, your 45, your 60, your 30, your 45, your 60. So, in essence, not only did we build what we're calling the unit circle up here, but we're also kind of reviewing, again, all the stuff from Chapter 2. Because Chapter 2 talked about theta here, or not theta prime, but this is theta prime, and this is theta prime, and this is theta prime. So we're still kind of building that idea of the reference angle into this idea of the unit circle itself. So I see people are still kind of working with this. What we're going to end up doing is we're going to start defining the points here, here, and here, and the values of the points. And so this is a little bit of Chapter 1 as well, because each point is built in a certain way. So this is kind of a good news, bad news situation. I'll put 360 degrees right down there, because 0 and 360 degrees are coterminal. There's another good key piece of language for us. Now, every single point on here can be written in a certain form. Each coordinate can be written as something a theta and something a theta. This is what's cool about the unit circle. Characteristics. I'll go right down here. Characteristics. And we'll start in degrees. Now, think back to Chapter 1. All the x values represent which trig function? Cosine. So the x values are going to be the cosine of theta. So this represents the x value in x comma y. So cosine is the x. What's the y? The sine of theta. Alright, so every point that we put on here is going to be in the form cosine theta, sine theta. So it's actually going to be those values that we already talked about, those special angle values. And the reason why I wanted to color code them is because now when you talk about 30 degrees and 150 degrees are the two angles that are going to match up. 30 degrees and 210, 30 degrees and 330, and you can kind of see that from the colors, as opposed to just drawing them and filling in a blank and going from there. Now, what do you think the radius is of the unit circle? What do you think the most simple radius is that you can possibly do? The easiest number that you can put in for the radius of a circle. Not 0, because if it's 0, it wouldn't be a circle. It's not 2. It's going to be 1. So the radius is going to be equal to 1. So this distance here, if I put the coordinates here, what's my x value? Since the unit circle goes out and it has a radius of 1, the center is right there. How far do we go along the x-axis? 1. How far do we go along the y-axis here? 0. What do you think the 90 degrees is? The x is 0 and it's 1. Now what do you think 180 degrees is? Negative 1, 0. And the 270? 0, negative 1. And that's going to kind of feed into everything that we've done so far. Now, what is the cosine of 30 degrees? Square root of 3 over 2. If you're starting at 1, you're going backwards. 1 is kind of like the square root of 4 over 4. We're going backwards, square root of 3 over 2. What is the x value of the next point? The 45 degree angle. Square root of 2 over 2. And what's the x value of 60 degrees? 1 over 2, and it gets you down to 0. So it goes square root of 4, square root of 3, square root of 2, square root of 1, 0. So square root of 3 over 2, its companion number is always going to be 1/2. If you have the square root of 3 over 2 as one of the points, 1/2 is the other point. But we also know that since we're starting at 0, we get the square root of 1 over 2. Now, what's the, whenever you see square root of 2 over 2, the sign is going to be, same thing, square root of 2 over 2. That's the special, of all the special ones, that's the specialist. Because they're equal to each other. Numerically, they're equal to each other. So if I see square root of 1 over 2 now for 60 degrees, what's the sine of 60? Square root of 3 over 2. So now for the first quadrant, we've built this entire thing. And you know what? It doesn't change. All that changes are the signs. Now, what are the cosines in this quadrant 2? Are they positive or negative? Negative. But when you see a blue line, it's going to be the exact same point as the blue line in the first quarter, in the first quadrant. So it's going to be negative 1/2 square root of 3 over 2. Now what's the point for the green point? Yeah, for here it's going to be negative square root of 2 over 2 square root of 2 over 2. Because the y's are still valid. And here it's going to be negative square root of 3 over 2 comma, didn't mess that one up. And you can kind of see for the x values, if we start from 0 and go all the way to 180, it goes from 1, square root of 4 over 2, square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. And it just happens to be all negatives over there. So, or you could go and know that's 1 and then go 3, 2, 1, 0. 1, 2, 3, 1. And if I'm at 1, what's the pattern going to be for this one? Is it going to go 3, 2, 0 or 3, 2, 1? Or is it going to go 1, 2, 3? for cosines, it's going to be 3, 2, 1. And they're still negative. Negative square root of 3 over 2. Negative square root of 2 over 2. Negative 1/2. And then we get down to 0. Now, are the sines or cosines, or the sines, are they negative down here? Yeah, they're negative too. So I'm starting at 0. So I'll get negative 1/2. Negative square root of 2 over 2. I'll put a comma there so it looks like we actually made a point. This is negative square root of 3 over 2. And it builds up to negative 1. Negative 1/2. Negative square root of 2 over 2. Negative square root of 3 over 2. Negative square root of 4 over 2. And then we're going to do the same thing going back this way. So the blue point is always, and this is why I wanted to color code everything. The blue point is always 1/2 square root of 3 over 2. But then I ask, what's positive and what's negative down here in quadrant 4? Is the cosine positive? Yeah, because the x's are positive. But the y's are negative, so the sine is negative. Now the green point here is square root of 2 over 2, square root of 2 over 2. No, it just, the 2 ran in. That's a 2 and that's a 0. Because of poor handwriting on my part. And so we get 0, 1/2 square root of 2 over 2, and we'll get square root of 3 over 2 up here. And we know our signs are still negative down here. And that is how you build the unit circle. And you're asking yourselves, oy, or you're telling yourselves, oy, or you're doing something about oys. But, ladies and gentlemen, love it, learn it, memorize it. The unit circle is absolutely essential to trigonometry. The unit circle is everything as far as trigonometry goes. And everyone's eyes are rolling and their heads are falling on the desk. But if you think about the patterns and you think about reference angles and you think about everything that goes into building it, all you need to know is this first, from 0 to 90, that first quadrant. Because the first quadrant flips over, then it flips upside down, then it flips over again. Or as soon as you know 30, if you figure out the reference angle, it would be 150. The reference angle for 30 here is 210. The reference angle here is 330. So the 30 degrees are all the closest angles to the x-axis. There's a lot of different ways that you can remember this. But this unit circle is a key for you. And considering now that I did the unit circle for you, I'm going to throw in a curveball. And you're not going to like it. Well, you'll probably like it. I like it. But as far as the unit circle goes, everything kind of okay? Any questions?